Hello and welcome to Science Time with your host, Yellowpurple. I took triple science, so some of this stuff might not occur to you, but still it's good to learn. In this episode, we will be going through some of the physics topics. Not all of them, because I can't be bothered. But I'm going to be going through a few things that might or might not be useful to you, so stay tuned. Okay then, to start off, we're doing some electromagnetism. Yes. And according to the 12th of September, I answered the question, how does a magnetic field induce a temporary magnet? And I wrote down, the magnet has a magnetic field which is being transferred to the temporary magnet. The magnet's domains are all pointing the same way because of the magnetic field. It's a temporary magnet because it's not always magnetised. Well, there you have it, folks. That is a temporary magnet for you. Yay! Now, for this next part, we'll be doing resistance. And according to the 13th of September, I wrote down, resistance slows down the current. Electrons collide into each other and the nucleus. This causes friction, meaning heat, which is wasted energy. Resistance is caused by colliding. And that is resistance. I think I said that wrong then, I don't know. Next, look at this transformer. Up here we have an important equation. Force equals magnetic field times current times length. That is important. You may need to know that. Now then, let's get into some fluid pressure. Yes, that's how you say it. Converting Celsius into Kelvin, or if you're intelligent, Kelvin into Celsius. Well, minus 273 Celsius is 0 Kelvin. 0 Celsius is 273 Kelvin. 100 Celsius, which is the boiling point of water, is 373 Kelvin. Minus 173 Celsius is 100 Kelvin. 665 Celsius is 938 Kelvin. Minus 200 Celsius is 73 Kelvin. That is very simple, right? Let's move on to absolute zero. At absolute zero, there's no movement, there's no kinetic energy, there's no pressure. In theory, there would be no volume, but this can't be true because everything has a volume. Yes, very intelligent. That's good to know. Always good to know. Now then, let's move on to pressure. Pressure is something I can't read at a normal angle. I'm really good at my own handwriting, aren't I? A normal angle is a right angle. A right angle can also be called perpendicular. That is useful to know. Pressure is how much force is spread over an area. That is very useful to know. And down here we have a useful equation. Pressure equals force over area. That is good to know. And here I've even written it out like that. PA is the unit for pressure. PA is pascals. Yes, that is also very good to know. Down here we have an example. Atmospheric pressure is 100,000 pascals. How much force is there on a 1p coin of 0.001 meters squared? Well, all we need to do is use the equation F equals P times A. So, we do 100,000 times 0.001, which equals 100. So therefore you get 100 newtons. That is good to know. Pressure depends on density and depth. Water is denser than air. The more dense, the more pressure. More weight, more pressure. Good to know. Density and depth increase weight. Here we have another useful equation. Pressure equals depth/height times density times gravitational strength, which is 9.81, because we're on Earth and that's what it always is on Earth. Well, that is very useful, and there it is written out in that form. P equals H times P times G. Very good to know. Very, very good to know. Now then, let's move on to floating. And as you can see, I messed up on the date. I'm such an idiot. An object will experience the force of upthrust due to the pressure difference. That is good to know. Oh look, another useful equation. Upthrust equals pressure difference times area underneath. You probably need to learn that. To calculate upthrust, first you need to find the pressure difference, and you do that using the equation pressure difference equals distance in depth times density times g. And then you use the equation F equals P times A, which is the upthrust, pressure difference and area underneath one, which we just learned about. If the force of weight is bigger than the upthrust, the object will sink. To float, the upthrust and the force of weight must be equal. Something will float if upthrust is equal or greater than weight. If the density is less than the water, it will float. If the density is more than the water, it will sink. And now for a word I cannot say. Elasticity. Elasticity. You get what I mean. If something is elastic, you can distort it and it will go back to its original shape. Elastic objects return to their original state after being deformed/distorted. Inelastic objects do not. Springs follow a linear, directly proportional relationship called Hooke's law. Force equals spring constant times extension. Weight equals mass times g. Elastic energy. Elastic energy equals half times spring constant times extension squared. Radioactivity. Oh wow, look at this diagram. Not everything gives out radiation. An unstable atom gives out radiation. A stable atom doesn't give out radiation. Radioactive decay is random. Nuclear radiation comes from the nucleus. There are 3 types of radiation: alpha, beta, and gamma. Alpha is strongly ionizing, weakly penetrating, and can be stopped by paper or a few centimeters of air. Beta is moderately ionizing, moderately penetrating, and can be stopped by a few millimeters of aluminium. Gamma is weakly ionizing, highly penetrating, and can be stopped by a few centimeters of lead or a few meters of concrete. Radioactive decay. Alpha can't go through a sheet of paper or a few centimeters of air. Beta can't go through a thin piece of aluminium. Gamma can't go through a thick layer of lead. A substance is radioactive if it gives out one or more types of nuclear radiation. You've heard of the song Park Life. Now get ready for half-life. A radioactive substance contains an unstable nuclei. Over time, there are less and less radioactive nuclei remaining. The half-life is the time taken for the number of radioactive nuclei in an isotope to half. Some isotopes have half-lives of fractions of a second, but others have half-lives of millions of years. The activity, also called count rate, gives you information on the number of unstable nuclei left. Count rate equals initial over 2n, and n is the number of half-lives left. Uses and word I cannot read. The more radioactive atoms, the more radiation. Radiation is around us all the time. Background radiation originates from a variety of sources, natural and artificial. Most background radiation comes from natural resources. Treatment of cancer. Ionizing radiation can also be used to treat diseases such as cancer. This is known as radiotherapy. Some ways of doing this involve radioactive substances which produce gamma rays used as beams of radiation. This kills cancer cells. Diagnosis of cancer. Gamma rays can be used to diagnose cancer. A tracker solution containing a source of gamma rays is injected into the body. The tracker collects where there are areas of abnormal activity, for example cancers. The gamma rays are then detected using a gamma camera. Alpha radiation is used for smoke alarms. Nuclear fission. Radioactive decay is a random process releasing alpha, beta or gamma. Fission is where large nuclei are split into smaller daughter nuclei. Fusion is small nuclei joining together to make larger nuclei. When radioactive nuclei react, this releases energy and makes them more stable. Fission is where large nuclei are forced to split into two. Wow, look at how fission works. A chain reaction is a series of reactants, each affecting the next. Not reactants, reactions. God damn it, Amy. We use graphite as a moderator to slow down the neutrons. Boron control rods absorb neutrons to slow down the reaction. A neutron is fired into uranium, causing the nuclei to split. This releases more neutrons, creating more reactions, meaning more nuclei split, meaning even more neutrons, causing the same reaction, and so on, meaning more neutrons each time. During this reaction, daughter nuclei are formed, which are smaller than before. This is a chain reaction. The daughter nuclei are then left behind. Now then, to finish this off, let's do a paragraph on lenses. A real image is formed when the light rays actually come together to form an image. The image can be captured on screens because the light rays have actually come together, so we can see where the image seems to be. Well, there you have it, folks. That's just about 15 minutes of physics. I think this was fun. I think it helped us revise. Some of it may not be helpful to you, some of it may be. I don't know. I don't even know if this video is going to work or not. But for now, thank you so much for watching. If you enjoyed it, please feel free to like this video if you did like it. Subscribe for abysmal content, and well, bye!